welcome everyone to this talk. Tonight, we'll be talking about a few things, but first off, as Travis mentioned, my name is John Motte, and I'm an engineer here at AppNexus, and my credentials are here. I'm going to have a link to the slides after this. You can probably see the link up there, but I'm hoping it's too small for anyone to actually use because you won't pay attention. Just kidding. So yeah, I'm actually based out of Portland, so I'm here visiting New York to do this talk and some other things. So it's great to be here in New York. So just to start off, I'm going to talk a little bit about what I'm going to be talking about. Super meta. So first up, I'm going to be covering a brief history of UIs at AppNexus, just kind of where we came from and how we got to where we are today and what some of the decisions we made along the way were. I'm going to talk about why we chose React, or what the other alternatives were that we evaluated, and why we chose React. I'm going to talk about our internal component library, which is the non-open source components that we work on. Then I'm going to cover LucidUI, which is the open source library that we put out this year. And finally, I'm going to talk about some general technology adoption tips. Sort of what are some of the things that we've learned in the trenches of adoption. So to kick it off, I'm going to talk a little bit about the history of UIs at AppNexus. And wanted to start off with a little timeline. So there's sort of three eras that I'm going to cover at AppNexus. The first one is PHP, and that spans all the way back to 2009. Then I'm going to be covering what I call artisanal jQuery, and I'll get into that in a minute. And then enter the React phase in 2015. So this is a little bit of a two-scale, sort of how we've moved through our architecture with our UIs at AppNexus. One quick note on that last slide, the charts and graphs in this presentation are all built with Lucid. So you'll be able to, and you'll notice that was a code pen. So if you take a peek at these slides after, you can click on the link, play with the code, mess around with it if you are curious about how I built this stuff. So first up is PHP. Love or hate it, it's everywhere. And it was what we chose when we first started building our UIs at AppNexus. And it was great for the most part. Like, we just needed to render pages, and we had data. So we would have templates. We'd take data in, render the template, and then serve an HTML up to the page to the customer. That's standard server-side rendering. But that doesn't always stay that way, as I'm sure many of you have experienced. There's a need for interactivity on the page. Can't just have static refreshes anymore. That's not enough, right? We need AJAX calls and dynamic stuff moving on the page and all this kind of things that we want in an application. And what started with just a smattering of JavaScript, sort of the like Rails philosophy of just a little bit of JavaScript here and there is great. That also never works. As I'm sure you all also have known, that eventually that little bit of JavaScript grows into a huge ball of JavaScript that is kind of like, what do I do with this? So we ended with giant complicated pages with huge files of JavaScript in them. And just to kind of show you one of those, so I pulled some stats on one of the pages that still lives in that side of our application. And you can see there's a little snippet of code here. We've got a immediately invoked function there, this is all in one single file. And it just gets the global context for the page, and it mutates all the things. That's a bit of a simplification for 16,000 lines of code, but you get the gist of it. It's all DOM mutation and fun stuff. So that one file we had was about 16,000 lines of code, and it had about 1,300 commits to it, and somewhere around 130 contributors over its life. So this thing is like Frankenfile. Everyone's touched it. And the other thing to note about this was we had like no unit tests for this. The only way we tested it was functional tests, essentially, which were like Selenium tests that would run the page and click through stuff and make sure that the behaviors were as we expected. So as developers, we didn't have like quickly responsive unit test that we could see. So it felt a bit like this. It's like, that was pretty awesome, but I don't want to do it every day. So moving on beyond that era, we come into the what I call artisanal jQuery. Being from Portland, I'm very into artisanal things, so this just seemed to fit. We actually, and the reason I call it artisanal is we didn't just do your regular jQuery thing. We took it a whole step, maybe 10 steps further. We wrote our own module system. So at the time, there was sort of AMD kind of coming out, and CommonJS was kind of also coming out, but there was no people didn't everyone use Webpack or this or that. So we decided to write our own. Fast forward, that's a bad idea. Please don't do it if you're thinking about it. Thankfully, JavaScript's evolved. We don't have to do that anymore. But it did have its benefits, right? We were able to move away from the one single file. We could move into smaller chunks of code that could require each other in, and we could reason about smaller bits of the system. And it also allowed us to do a bit more testing, so it was easier to write unit tests against. It wasn't great. A lot of the times the tests wouldn't work on your local machine, and you'd have to wait till the build server ran them, and then sometimes you'd literally run it like 5 times just to try and get it to pass. You'd be like, oh, yes, it passed. So not a whole lot of confidence there. So this is an example of what that looked like. So this is our own module system. You can see we're pulling in jQuery, underscore, and then another component, like dialog, which is a dialog box. So we've got $, underscore, and dialog. But it still had the same fundamental problem that the other one had, which was we were still mutating all the stuff inside of the component. It was yeah, we have these smaller files, but we're still just all operating on the DOM, and you have no idea what the lines above you are going to do or the ones below you are going to do. So we bump into some of the same issues here. Boop. Hope that doesn't blow up. So we wanted to move on from that. We were kind of tired of having our own module system. And it was difficult to work with. As a new person, I had no idea. I'd never seen this module system before. It was tough. So we wanted to evolve from that and move forward. And the first step to evolution is evaluation. So this was around early 2015 is when we started saying, we want to move on from where we are. We don't want to do this homegrown module system anymore. We want to try something else, and we want to use more open source. We want to base our stuff on open source technologies that the community adopts and that have momentum elsewhere. So the 3 things we evaluated were mainly Ember, React, and Angular. And really, Angular was kind of off the plate for us pretty early on, just because a lot of us were JavaScript engineers, and we weren't super interested in the way that Angular puts a lot of stuff into the HTML. We wanted something that was more JavaScript-centric. So really, the 2 alternatives for us were Ember and React. And I'll go into a little bit more detail about that in a second. The third bit of information that was interesting is we had a desire to go to microservices. And I put that in quotes because who knows what microservices really means. We had a monolithic UI that was in one application, and we wanted to have teams work on smaller bits of it. So that's what we meant by microservices. Break away from one single UI with a ton of contributors to that one code base. And here's another little visualization of what happened to the company. So the red bars represent our first Ember application, and the blue bars represent, and the different shades are different React applications that were started. And this goes back to early part of 2015, leading up to around now-ish. So you can kind of see in the beginning we had 2 main applications that got started as sort of how are these technologies going to work in our infrastructure? And you can see that React just kind of exploded. So over time, it won out as the better alternative between the 2. And we continued adoption on that side. So why did React win versus Ember? Well, the big reason for us was that it embedded in an existing app. And this is something that a lot of people talk about when they talk about React, and we found it to be true for us too. When you're considering adopting something, it's really hard to just wholesale replace your existing pages and applications. So React was able to kind of come in to the existing code base. We were actually even able to get it in our existing, working in our existing module system, and so we were able to use it that way. Another big win of React is its roots in functional programming. So the thing that we all loved about server programming was the concept that your UI can be a pure function of your data. And I'm sure if any of you have worked with React, you're familiar with this, so if I'm repeating stuff, I apologize, but basically you have your data that comes in, it gets run through React, and React handles all the DOM mutations for you, so you get kind of this uniformity and single flow through your application. Thirdly is the community momentum and tooling. To be honest with you, having Facebook attached with whatever framework you choose is not a bad idea for adoption, because everyone seems to like love stuff Facebook puts out. It's like, oh, they came out with a new library. Gotta go check it out really quick. And everyone's using it. It has 5,000 stars on GitHub. So that doesn't hurt either. But the benefit to that is that people are looking at it and working on it and trying to improve it. So that was a big win. And lastly is better unit tests. So along with this concept of having your UI as a pure function, you get this side effect of you can just set up your data states, run them through, and then test the output. It's a lot more straightforward. You can have a lot more unit tests with less friction writing them. So what are some of the downsides? Because they're not all upsides. I'd be lying to you if I said they weren't. The big one is the ecosystem learning curve. When you first start in React, there's a ton that's thrown at you. There's like, you got to learn Webpack, and you got to learn React, and what's JSX? Is this terrible? Is this okay? There's a bunch of stuff. And then there's a lot of churn in the tooling. Seems like every week there's some new piece of technology coming out in React, and we all hope it's going to solve all our problems. But that comes with a cost, right? You have to continually be looking at these or not looking at them, but they do provide, their distractions. So just a quick snapshot of where we are. This is current day. We are now off of one application. We have 17 UI applications running in production. Each application has an average of about 12 contributors to it. And there's about 600 commits to each of those applications. Just to kind of give you an idea of how we've spread from like 140 working on one thing. And I actually looked it up. We have 18,000 commits on our main application. It's just crazy. So one of the things about React was we realized pretty quickly that we needed components. We wanted to keep our UIs consistent across all these little applications, and we needed a library to handle that. So this really started as a grassroots effort amongst the engineers who saw this need and wanted to share code. We're all about reducing duplication, so we kind of got together and said, let's start building components and let's put them in one place. And we got an internal NPM server, which was a big push forward to doing this. And we called it ANX React, which is a terrible name. Don't name your library the same name as the thing you're trying to. I can't tell you the number of times people are like, so you guys wrote React? We're like, no, it's ANX React. So it's a bad name, but we have to live with it now. This is a little snapshot of what that page looked like when we first built it. So we started with the venerable button, very simple component, and we had some examples of it. So for the most part, that was a success. Engineers were writing components and contributing them to this code base, but there were some challenges that we pretty quickly ran into. And those were three main things with our first component library. The first one is inconsistent state management. So if any of you have worked on React components, you know that the components can have their own internal state. And essentially, when you render a component, it can take over its state and do its own thing inside. And the problem is, sooner or later, someone comes along and they say, oh, I want to control this bit of state. And suddenly that component doesn't work for them anymore because they don't have enough control over it. And that was a big problem for us. That was one thing we were constantly looking for a solution to. The second big thing was we had inconsistent component APIs. One of that was just naming conventions. Another big part of that, though, was do you allow people to pass in an array of strings or an array of nodes or an array of JSX, that kind of stuff. Those kinds of questions were really tough to answer. And thirdly, we didn't have any dedicated resources to it. So we were all kind of working on this internal component library, but there was no one owner. And there was no one team who said, let's spend time and think about this and make it consistent. As far, honestly, like you all know a library, if a bunch of engineers are making a UI library, it's going to be ugly. And it was. So we wanted to fix that too. So we were able to, well, first off, we felt pretty smart. But it still was a little awkward, you know? This doesn't quite feel right. So we decided to put a team around it. And we got approval for a budget, a small team of people to work on this. And we were able to get the time of our UX team as well to work with us, because they have a very specific way of thinking about how we build our UIs for our customers, and we really wanted to incorporate their approach to things into the component library that we built. And we decided to make an open source arm of the component library. And we have two libraries. So we have the internal one, which has our components in it still, that have business-specific logic in them, but the open source Lucid is where we put all our components that don't have stuff that's technically specific to AppNexus. The reason we didn't just use another open source library is sort of the whole idea of like the pattern library thinking that's kind of gone around in the designer community, which is you have a certain, you want your UIs to behave in a certain way that fits your use case. And ours is very specific. We're very desktop focused for better or worse right now, and we show a lot of data on our pages, lots of big informational displays about lots of numbers and lots of information showing. And so we wanted our components to reflect that philosophy. And honestly, building components in React is so much easier than the alternatives that it made sense. It wasn't a huge barrier for us to be able to do that. So let me introduce LucidUI, which is where we came to through all of this. So Lucid's available on GitHub, and we do all our work on it up there. It's under the AppNexus repo. Let me just open that up here. You can see that we've got some badges. Pretty nice. They're all green. That's good. Or sort of a shade of green. We also have a link up here to the docs, which is more important than the README, right? So let me open this up here. So this is our docs page that shows a list of all our components, breaks them down by hierarchy. It's got a README information in it. But really, most importantly, is it's got an Easter egg that's dedicated to my hometown of Portland. I'm very proud about. And since I'm from Portland, I had to put a bird on it. Yeah, it's mandatory. And the background, quick story. The Portland International Airport got rid of their carpet, and it looked like this. It was awesome. It's from the 80s. Everyone loves this carpet. People have socks with it, T-shirts, and they ripped it out and put in a new one. So as a Portlander, it's my goal to try and keep this carpet alive. So moving back onto the actual library, I'm not going to go super in depth on like every single component But I'll give a quick rundown of how we do our docs. It's very similar to something like you'd see on Material UI or another component library like Bootstrap kind of thing. But it's very React specific, right? Because this is a React component library. We have the name of the component, but we also show what other components that component is made of. So you can kind of traverse the tree of how we compose our components together. Just a description, and then we document each of the props that that component takes with example, like what are the defaults and stuff like that. And then down below, we have a bunch of examples with code snippets for each of the examples, and obviously the component itself working, and then the various enumerations on the props. So this is pretty similar to what you'd find on other component libraries. We took the approach of putting more components in this library than breaking them out into small libraries, and that's kind of a contentious thing in the React community. We found that working with React as a peer dependency is a bit of a challenge, and so it's easier if we reduce the number of libraries that have a peer dependency on React. So essentially what that means is we just put more components in here. And you can see like we have quite a bit in here. We even have charts and graphs, which is what I built all the charts with in my slide deck as well. These are actually built on D3 under the hood, so we're not completely rewriting everything here. But we do have a lot of stuff in here, so it's kind of nice. It's sort of batteries included approach to the component library. So you flick back here. That's the docs page. Feel free to check it out on your own if you're interested. Let me just continue forward here. So this is another timeline. And this is breaking down just that React era, what we've been up to there. So React was introduced in early 2015. And ANX React, which is that terribly named internal component library, started shortly thereafter. And then in early 2016 is when we started Lucid. And all of three of those are continuing today, obviously. So another important thing for the members on my team who we work primarily on Lucid, we also own the core infrastructure for UIs, like the tools that developers use to make the UIs, is we track usage of the two libraries internally. And these numbers are just internal usage. We don't put trackers in our components that call back to an API or anything, because that would be evil. So these are all just internal usage of the components. What's cool about it is the orange line is Lucid and the blue line is ANX React. So up and to the right, that's pretty good. We've seen about a 300% growth in the number of components used in our UIs in the last 5 or 6 months. So that's super encouraging for the team, and it helps us decide, what we need to work on and what could be deprecated, what's not being used so much. So that's great for us. So rather than go through say, hey, Lucid is the most amazing library, everyone should use it, that's not what I'm saying about Lucid. It is a good library, and it has some cool ideas in it and some really nice components, but I wanted to take some time to talk about a few of the ideas that I think are really cool about Lucid that I haven't seen in other component libraries. Sort of what differentiates it. And these ideas are not exclusive to Lucid. They could be adopted elsewhere as well, so that's what I'm hoping people will find interesting. So first up is what I call hybrid components. And it took me a while to come up with this name, but given climate change and everything, it seems like a good term, even though this does not help the environment, sadly. So let me just break this down a little differently. So this is an example here, and let me make this a little bigger. So this is one of our components, the expander panel. And even though it says can't touch this, you guessed it, you can. And guess who's hiding behind it is MC Hammer, giving us a little show. So this is a pretty basic component. It just expands and collapses and contains content. But what's interesting is if you look at the code over here, we're not actually maintaining that state in this example. So you can see we're just rendering the expander panel with a header that says can't touch this. And then in the content of it, we just have a little image and then it's the end tag of that, and then we're rendering it out to the page. So the component in this case is maintaining its own internal state. And that's nice because sometimes we don't want all of a component state in our Redux stores. Maybe we don't care about certain bits and pieces. Like, for example, I don't necessarily care that a user has this open or closed. It's nice to be able to not have to put that in a Redux store. So it gives a bit of flexibility. And let me show you the alternative here. I'm going to comment out this line and instead open up this one. So in this case, it's the same. It's a header with can't touch this, except this time we're setting the prop of is expanded to false. And what that's doing is this, in the spirit of being a hybrid, it's essentially saying I want to take control from the component of these props. So no longer, I don't want it to control its own internal state, I want to control that. So by passing false to this, it makes it so that the component can't be interacted with anymore because it's permanently set to false. So the cool thing about that is you can control it with your Redux store if you want, but you don't have to. And this is a really trivial example. It only has one bit of state about the component. But you can imagine with a more complicated component where you have lots of bits of state, you may not care about all of them. You may only care about some of them. So that's pretty useful. Let me show you how we actually implement that. So this is the source code for the expander panel. It's ES6 goodness. And you can see here we're importing a set of reducers on this line. And essentially the expander panel is written as a stateless component. It doesn't actually have any this.setStates in it. It all relies on callback functions, callback props, and props. So if we look, it actually has an onToggle function that gets a prop that gets invoked when the user tries to open it up. And it also has the isExpanded prop, which controls whether it's open or closed. So we get to write our component as regular, completely stateless. But what we do is we actually have our own wrapper around React Create class, which is very simply just a pass-through to React Create class, except it looks for a couple properties on the object that we care about. And one of those properties is the reducers property, which this is some ES6 here. And it's basically, it's an object with properties that map to the callback props. So I'll actually show you what the reducers file that lives alongside this looks like. And I apologize if this looks terrible, because I don't normally work in solarized light. But presenting in dark colors doesn't work very well. So it's all kind of wonky, and it's bugging me. But anyway, there's only one reducer for this component, and it's onToggle. And very simply, it takes in state, which is initialized to an empty object. And it just extends, or like object assign essentially is what this is doing. And it inverts the isExpanded state property. And all we do is we take these reducers and we put them on the component, and then we run them through one of the utilities we have, which is build hybrid component. And it takes the reducers and it takes the stateless component and it produces a hybrid component, which is what we export by default from the library. And so that's all we have to do to get that hybrid interaction working, which has been really cool for us. So that's one of the ideas that's been really neat. I actually learned about, later on, there's a library called Uncontrolled that has a very similar idea as this. Their implementation's a little different, but turns out we weren't the first people to have it, but we didn't know about it when we wrote it. So sort of parallel inventing there. So that's the idea. That's hybrid components. Next up, I want to talk about props or children. And really quickly on the previous one, if you remember, I mentioned the 3 problems we had with our internal one, which the first issue we ran into was state management. And the hybrid components helped us solve that problem of should components have their own internal state. It's like, no, we can actually put them in reducers. And then those reducers can live alongside the component. The second idea that's interesting is this props or children concept. And let me open this one up here. So here we have, again, the same component. Can't touch this. And right now it's just managing its own state. We don't care about controlling it. But you'll notice that this prop header starts with a capital letter. And that's a convention we use to signify that, hey, there's another way to pass in this prop besides just as a regular prop on the parent level. And where this is useful is, say we wanted to take this component and make it a little more GeoCities. Kind of go, 1999 on it. So we could pass some JSX in here, something like this, and put a div or whatever in there. But instead, since the property starts with a capital letter, a convention we have is you can actually pass it in. Oh, whoops, that's going to break it. So you leave the parent here, but you can actually pass it in as a child element of that component. And you see I wrapped the content in a marquee. So this is really nice because it encourages your consumers to compose the component with other things together. And composition's easier when you don't have to render this thing necessarily somewhere else and then insert it in as a regular prop. This keeps kind of the flow of the component without breaking. There's a lot more flexibility if you need to put, more. So if I wanted to put a bold tag around this part, it totally works just like regular JSX. Assuming the B tag still works. Who uses that anymore? Who even uses marquee? Why? Is there a site still using marquee? Do they need to keep that around? I don't know. So that's props or children. And that's a convention we have for any of our components that have a capital letter. And sometimes what's cool about this is it's not just one property, but say you have a list of items. You can actually have multiple in here, and the component is able to pick up multiple if it makes sense in the context of that component. So that's props or children. And those are 2 of the interesting ideas from Lucid I think are worth sharing. Some details about Lucid. As I kind of mentioned or alluded to earlier, it's pretty desktop focused, so our components are not responsive. If you're looking for a mobile framework, look further. We want to move more into the mobile space, but it just hasn't been a priority for us yet. But I have a feeling that it's going to be soon. We use less to do all our styles. So essentially, you have to drop a CSS link tag into your page as well, and it will do all the styles. We do our own namespacing of the sort of similar to a SMAX or a BEM approach for styles. So all our components are scoped by name, so they won't stomp on your existing styles. Another thing we're really proud of is we have 90% unit test coverage. So we spend a crap ton of time writing tests and testing across browsers. So that's some of the details about it. I wanted to take a minute to talk a little bit about general adoption of technology. So this is a problem we're constantly running into. I think probably every tech company is. How do we move forward and keep the old things alive? And I think the biggest lesson that I learned from this whole experience is go grassroots. Every time I've seen something that starts from the top down and comes down to engineers, it always seems to have doesn't seem to work as well. Really where we found benefits and things worked well for us is we started sharing with our coworkers, and we were able to do proof of concepts, do meetups together, share stuff together, and that was a huge boon for us. So React kind of spread amongst the engineers at AppNexus and moved its way up. And that's kind of how things work for us, and that I think is huge for adoption in general. If you think something's cool, do proof of concept, try and make your coworkers think it's great too. Second tip is don't rewrite. And this also goes back to the point I made earlier, is that React was great because we were able to put it in pages that were pre-existing. And for a business, that's super important because it's like you got to change the engine out while the car's still running. And that can be difficult. So if the technology that you're trying to incorporate, find a way to make it run alongside your existing stuff for at least some period of time. And do incremental adoption. So have a plan for slowly moving your things forward onto whatever new technology you're trying to adopt. Thirdly is rewrite. I know you're thinking, but wait a minute, you just told us don't rewrite. Well, I did. But when you factor time into this, it makes a little more sense. So there are certain pages that make sense to rewrite. Sometimes it's too much to just go from the bottom up and work your way up into a page and rewrite it. Sometimes you have to take a fresh crack at something. And this is only really possible once the technology's proven itself and it's gained enough momentum amongst engineers in the organization to be able to have the clout to do a rewrite of a certain part of your application or stack. And another key indicator, I think, for that is when something needs maintenance. So it does not make sense to rewrite something that you're not going to have to work on very often. And that can be a hard question to answer sometimes. How much do we need to work on this page in the future? But it's sort of a try your best to think about, where you're going to get the most bang for your buck, and try and collect metrics around that if you can. Failure. Poor Anakin. I'm sure some of you are in pain right now, just looking at this slide. So let me fix that for you. Learn from your mistakes. This is probably the most important thing I've learned through this process, is know that you're going to have failures. And you're going to break production probably in some way, shape, or form, no matter how much you try and prepare for these things. And just expect that it's going to happen and try and learn from it. And try not to get down too much. So we all have some degree of imposter syndrome, and we want to move our UIs forward, we want to move our applications forward, and we're trying our best to bring stuff that's going to make life better for the developers, for our users, but we have to know that we're going to fail along the way. So expect it and learn from it. So, in summary, React has been awesome for us with web apps. A coworker was telling me a story from when we first started introducing React that I thought was really interesting. We had an existing page, and we had a new page written in React. And he was talking to the product owner, and he basically came up with an estimate of how long it would take to do the same feature in the old page, which was our sort of jQuery spaghetti soup thing, and how long it would take to do in the React app. And it was 3 hours to do it in the React app and 3 days to do it in the other one, and it wouldn't have unit test coverage or whatever. So it was that was a huge realization moment for us. It's wow, we're going a lot faster than we were before. This is great. Component libraries are great for consistency. Whether you choose to use someone else's component library or if you have the resources to build your own that's catered to your use cases, React is a great tool set for doing that. And really just in general, those functional approaches so there's a lot of libraries out there right now that are very React similar, and I think that the fundamental ideas behind them are what enable these kinds of things like components, which is the pure function approach to mutating the DOM. So whatever you decide to do, try and break your reusable stuff out into components. It's great for consistency. I had to get some emojis in here, It wouldn't be, a 2016 presentation without them. Thirdly, it was LucidUI. Here it is. It's great. Check it out. If anything, if you don't end up using it, that's cool. But maybe I hope those ideas are interesting to you, and maybe will help you in whatever you're working on. And lastly, on the adoption bit, go grassroots. Share with your coworkers. Generate some excitement. Get people interested in realizing why this is a good thing. And that can be an embarrassing thing sometimes because people are going to ask you questions you don't always know the answer to, but it's going to push you to figure out the answers to those. And that's a good thing. And finally, make mistakes. It's a key part of moving technology forward. Try and learn from it. So there's a link to the slides I promised. Feel free to check them out. And thank you.